The installation of a 200 amp service panel could range from $2,000 to $3,000. The cost of a receptacle outlet could range from $50 to $100. A switch outlet may cost between $50 and $100. The price of a lighting outlet could be approximately $75 to $150. Ceiling fan installation might be in the range of $100 to $200. Installing a subpanel could be $250 to $500. The installation of feeder lines could be $50 to $100 per foot. These figures are approximate and are subject to fluctuations based on the dimensions of the home, the materials selected, and the prevailing labor expenses. Permits and inspections might be mandated, which could augment the overall expenditure. It is advisable to engage a licensed electrician to guarantee safety and adherence to electrical codes. Local electrical codes and regulations can differ across regions, so it's essential to check with local authorities for accurate compliance. Firstly, let's delve into the service panel installation. This is the core of the electrical system, responsible for distributing power throughout the residence. The 200 amps rating indicates the capacity of the service to handle electrical loads. The quoted price range encompasses the cost of the panel itself, the necessary wiring, and the labor involved in installing and connecting it to the electrical grid. This typically includes the main breaker, which serves as the primary disconnect for the entire electrical system. Secondly, we have the electrical outlets and fixtures. This segment covers the various types of outlets and fixtures commonly found at a home. A receptacle outlet, commonly known as an electrical outlet, provides a point of connection for appliances and electronic devices. The cost includes the outlet itself, the wiring, and the labor to install it in the wall. A switch outlet controls lighting fixtures or other electrical devices. Similar to receptacle outlets, the cost covers the switch, wiring, and installation labor. Lighting outlets refer to the points where lighting fixtures are connected. The cost here includes the wiring, mounting hardware, and labor for installing the fixture. Ceiling fan installation involves mounting the fan to the ceiling and connecting it to the electrical wiring. The cost covers the fan mounting hardware, wiring, and labor. Thirdly, the discussion moves on to subpanels and feeders. Subpanels are smaller electrical panels that branch off from the main service panel. They are used to distribute power to specific areas of the house, such as a workshop or a home theater. The cost covers the subpanel itself, the wiring, and the labor to install it. Feeders are the wires that run from the main service panel to the subpanel. The cost is typically calculated per foot and includes the wire and the labor to install it. Keep in mind some additional considerations. The prices provided are estimates and may not reflect the actual cost of the project. The final cost will depend on several factors, including the size of the house, the quality of the materials used, and the prevailing labor rates in the area. Permits and inspections are often required for electrical work. These can add to the overall cost of the project, but they are essential to ensure that the work is done safely and to code. Hiring a licensed electrician is highly recommended. A licensed electrician has the training and experience to perform electrical work safely and to code. They can also help you obtain the necessary permits and inspections. Electrical codes and regulations vary from area to area. It's important to consult with local authorities to ensure that your electrical work complies with all applicable codes. Understanding electrical wiring involves several technical aspects. Wire gauge is a critical factor. The gauge of a wire refers to its thickness, and it's crucial to use the correct gauge for the amount of current the wire will carry. Using a wire that is too thin can cause it to overheat and potentially start a fire. The National Electrical Code, or NEC, specifies the minimum wire gauge for various applications. For example, for a typical 15 amp circuit, a 14 gauge wire is usually sufficient, while a 20 amp circuit requires a 12 gauge wire. Always consult the NEC or a qualified electrician to determine the correct wire gauge for your specific application. Circuit breakers and fuses are safety devices that protect electrical circuits from overloads. When the current in a circuit exceeds the rated capacity of the breaker or fuse, it will trip, interrupting the flow of electricity and preventing damage to the wiring and appliances. Circuit breakers can be reset while fuses must be replaced. Grounding is another important safety feature. Grounding provides a path for stray electrical current to flow back to the source, preventing electric shock. All electrical outlets and appliances should be properly grounded. Ground fault circuit interrupters, or GFCIs, are special types of outlets that are designed to protect against electric shock. They are typically installed in areas where there is a risk of water exposure, such as bathrooms and kitchens. GFCIs monitor the current flowing through the circuit and will trip if they detect a ground fault, quickly cutting off the power and preventing a potentially fatal shock. Arc fault circuit interrupters, or FSIs, are another type of circuit breaker that protects against electrical fires. FSIs detect arc faults, which are dangerous electrical discharges that can occur when wires are damaged or connections are loose. When an arc fault is detected, the FSI will trip, cutting off the power and preventing a fire. Electrical boxes are enclosures that protect electrical connections and provide a mounting point for outlets, switches, and fixtures. Electrical boxes must be properly sized and installed to ensure that the wiring is protected and the connections are secure. There are various types of electrical boxes available, including metal and plastic boxes. Conduit is a protective tubing that is used to run electrical wires. Conduit is typically used in areas where the wiring is exposed or where it needs to be protected from damage. There are different types of conduit available, including rigid metal conduit, electrical metallic tubing, and flexible metal conduit. Wiring methods refer to the ways in which electrical wires are installed. There are several different wiring methods permitted by the NEC, including non-metallic sheath cable, armored cable, and conduit. The appropriate wiring method will depend on the specific application and local codes. Non-metallic sheath cable, often referred to as Romex, is a common type of wiring used in residential construction. It consists of 2 or more insulated wires enclosed in a plastic sheath. Armored cable, also known as BX cable, is similar to non-metallic sheath cable, but it has a metal armor that provides additional protection. Electrical metallic tubing, or IMT, is a thin-walled metal conduit that is commonly used in commercial and industrial applications. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations. It covers everything from wiring methods to grounding to overcurrent protection. The NEC is updated every 3 years, and it's important to stay up to date on the latest requirements. The NEC is not a law, but it is widely adopted by state and local governments. It's important to note that electrical work can be dangerous, and it's always best to hire a qualified electrician. If you're not comfortable working with electricity, don't attempt to do it yourself. Firstly, always turn off the power to the circuit you're working on. Secondly, use the right tools for the job. Thirdly, follow all applicable codes and regulations. For example, if you are installing a new outlet, you will need to connect the wires to the correct terminals. The black wire, which is the hot wire, should be connected to the brass terminal. The white wire, which is the neutral wire, should be connected to the silver terminal. The green wire, which is the ground wire, should be connected to the green terminal. Always make sure the connections are tight and secure. After you have connected the wires, you can install the outlet in the electrical box. Make sure the outlet is flush with the wall and that the screws are tightened securely. Finally, you can turn the power back on to the circuit. After turning the power back on, test the outlet to make sure it is working properly. You can use a voltage tester to check the voltage at the outlet. If the outlet is not working properly, turn the power back off and check the wiring. In addition to the above, consider the following points. Breaker sizing is essential. Breakers are sized to protect the wire. If the breaker is too large, it will not trip in the event of an overload, and the wire could overheat and start a fire. The NEC specifies the maximum breaker size for different wire gauges. For example, a 14-gauge wire is typically protected by a 15 amps breaker, while a 12-gauge wire is typically protected by a 20 amps breaker. Voltage drop is a decrease in voltage along a conductor. Voltage drop can occur when the wire is too long or when the load is too high. Excessive voltage drop can cause appliances to malfunction and can even damage electrical equipment. The NEC specifies the maximum allowable voltage drop for different types of circuits. Surge protection protects electronic devices from voltage spikes. Voltage spikes can be caused by lightning strikes, power outages, and other events. Surge protectors divert excess voltage away from electronic devices, protecting them from damage. Smoke detectors are life-saving devices that detect smoke and alert occupants to a fire. Smoke detectors should be installed in every bedroom, hallway, and on every level of the home. Carbon monoxide detectors are devices that detect carbon monoxide, a colorless, odorless gas that can be deadly. Carbon monoxide detectors should be installed near sleeping areas and on every level of the home. Remember, always consult with a qualified electrician to ensure the electrical work is done safely and correctly. When estimating the cost for electrical work, remember that material costs can fluctuate. Copper prices, for instance, can significantly impact the cost of wiring. It's always wise to get a detailed quote from a licensed electrician that breaks down the costs of materials and labor. Moreover, consider future needs when planning your electrical system. It might be worthwhile to install a larger service panel than initially required to accommodate future expansion or additional appliances. This can save you money in the long run by avoiding the need to upgrade the service panel later. Energy-efficient lighting can also contribute to long-term savings. LED lighting consumes significantly less energy than traditional incandescent bulbs, reducing your electricity bill. While the initial cost of LED lighting might be higher, the energy savings over the lifespan of the bulbs will typically offset the initial investment. Smart home technology can also enhance the functionality and energy efficiency of your electrical system. Smart thermostats can automatically adjust the temperature based on occupancy and preferences, reducing energy consumption. Smart lighting systems can be controlled remotely, allowing you to turn lights on and off as needed. Furthermore, it is important to consider the accessibility of electrical outlets and switches. The Americans with Disabilities Act, or ADA, provides guidelines for the placement of outlets and switches to ensure accessibility for people with disabilities. These guidelines specify the height and location of outlets and switches to make them easier to reach and operate. Finally, remember to keep your electrical panel clean and free of obstructions. This will ensure that the panel is properly ventilated and that the breakers are easily accessible in case of an emergency. Periodically inspect the panel for any signs of damage or corrosion, and never attempt to repair a damaged electrical panel yourself. Always call a qualified electrician. In addition to the initial installation costs, be aware of the ongoing costs associated with electricity consumption. Your electricity bill will depend on your energy usage, which is influenced by factors such as the size of your home, the number of appliances you use, and your lifestyle. There are several ways to reduce your electricity consumption and lower your electricity bill. Energy-efficient appliances can significantly reduce your energy usage. When purchasing new appliances, look for the Energy Star label, which indicates that the appliance meets certain energy efficiency standards. Proper insulation can also help reduce energy consumption. Insulation helps to keep your home warm in the winter and cool in the summer, reducing the amount of energy needed to heat and cool your home. Sealing air leaks can also improve energy efficiency. Air leaks can occur around windows, doors, and other openings in your home. Sealing these leaks can prevent drafts and reduce energy loss. Consider renewable energy sources, like solar panels, to further reduce your reliance on the electrical grid. Solar panels convert sunlight into electricity, which can be used to power your home. This can significantly reduce your electricity bill and help to protect the environment. Before any electrical work begins, it is crucial to have a clear plan that outlines the scope of the project, the materials to be used, and the timeline for completion. This plan should be reviewed and approved by a qualified electrician. This plan helps to ensure that the project is completed on time and within budget. Consider the placement of outlets and switches carefully. Think about how you will use the space and where you will need access to electricity. It is often better to have too many outlets than too few. Proper planning can help to avoid the need for extension cords and power strips, which can be unsightly and can pose a safety hazard. Take the time to research and select the right electrical contractor for your project. Check their qualifications, experience, and references. Make sure they are licensed and insured. A reputable electrical contractor will provide you with a detailed quote, answer your questions, and complete the work to a high standard. Lastly, ensure that all electrical work is inspected by a qualified inspector. An electrical inspection helps to ensure that the work has been done safely and to code. Electrical inspectors will check the wiring, grounding, and other aspects of the electrical system to make sure that they meet the required standards. Passing an electrical inspection is essential for ensuring the safety of your home and its occupants. Remember to keep all electrical cords and cables in good condition. Damaged cords and cables can pose a serious electrical hazard. Inspect cords and cables regularly for any signs of wear and tear. Replace any damaged cords or cables immediately. Avoid overloading electrical outlets. Overloading an outlet can cause it to overheat and potentially start a fire. Do not plug too many appliances into a single outlet. If you need to plug in multiple appliances, use a power strip with a surge protector. Never run electrical cords under rugs or carpets. This can damage the cords and create a fire hazard. Keep electrical appliances away from water. Water can conduct electricity and create a shock hazard. Never use electrical appliances near water, such as in the bathroom or near a sink. Always unplug electrical appliances before cleaning them. This will help to prevent electric shock. If you are unsure about any aspect of electrical safety, consult a qualified electrician.